Hi, let's find the 6 values of k. Yes, it's very obvious that k is equal to 3, but what of the other 5 additional values of k? So I'm going to take you through on how to go about this. Thank you so much for watching. Now, first, let's bring this to the other side of the equation. Okay, so we have k to the power of 6 minus 3 to the power of 6 is equal to 0. So note that when you have a to the power of m times n, that this is equal to a to the power of m raised to the power of n. So that means that this power can be expressed as product of its factors. Therefore, we can write k to the power of 3 raised to the power of 2, right? Since 6 is same thing as 3 multiplied by 2, minus 3 to the power of 3 raised to the power of 2 is equal to 0. Now, if you look closely, you can see that what we have now is difference of 2 squares. Therefore, we are going to apply this algebra identity that states that a squared minus b squared is equal to a minus b multiplied by a plus b. Okay, now in this case, our a is k to the power of 3, while our b is 3 to the power of 3. So we are going to expand this in this form. So we are going to write a minus b, that is k to the power of 3 minus 3 to the power of 3, multiplied by a plus b, that is k to the power of 3 plus 3 to the power of 3. Okay, all right, now this is equal to 0. Therefore, please ignore the background sound. I actually traveled so I'm in the village. I'm so sorry about that. All right, so let's continue. Now from here we can say that k to the power of 3 minus 3 to the power of 3 is equal to 0, and that k to the power of 3 plus 3 to the power of 3 is also equal to 0. Now from here, if you are tempted to transfer this to the other side, you'll be tempted to get only one solution. So what we are going to do is, for this we are going to apply our algebra identity. Do you understand? Yes, for here the algebra identity. So let me write, for k to the power of 3 minus 3 to the power of 3 equals 0. The algebra identity that states that a to the power of 3 minus b to the power of 3 is equal to a minus b multiplied by a squared plus ab plus b squared. Okay, so in this our case, our a is equal to k here, and our b is equal to 3, right? So we are going to expand in this form. So we are going to write a minus b, that is k minus 3, multiplied by a squared, that is k squared, plus ab, that is 3k, plus b squared, that is 3 squared, right? This is what we use to replace this, is equal to 0. So we can now write that k minus 3 multiplied by k squared plus 3k plus 9 is equal to 0. So from here we can see that k minus 3 is equal to 0, and from here we can see that k squared plus 3k plus 9 is also equal to 0. Now if we solve the left side, we can see that k is equal to 3, and this is the first and the obvious value of k. Now let's get the next 5 values, which are very easy to get. Okay, if this is the first time you're seeing this amazing channel, please click on the subscription button, turn on your notification bell so that you don't miss our amazing videos. We upload videos daily, so please tune in at your convenience to watch our new uploads, and give us a thumbs up if you're actually enjoying this video. Thank you very much. Now for this, okay, you can only solve this using the quadratic equation formula, and the quadratic equation formula states that to get this k, okay, is going to be equal to a squared plus 2, oh sorry I'm so sorry, it's going to be equal to, k is going to be equal to minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. Okay, that is the quadratic equation formula. Now here our a is the coefficient of k squared, which is 1. Our b is the coefficient of k, which is 3, and our c is our constant, which is 9. All right, so if we substitute those values into this place, we have that k is equal to minus b, that is minus 3, plus or minus square root of b squared, that is 3 squared, minus 4ac, that is 4 multiplied by 1 multiplied by 9. Okay, everything divided by 2a, that is 2 multiplied by 1. So we have that k is equal to minus 3 plus or minus square root of 9 minus 9 times 4 is 36, right? Divided by 2. So we have that k is equal to minus 3 plus or minus the square root of, now 9 minus 36 will give us what? Minus 27, right? So we have minus 27 divided by 2. So k is equal to minus 3 plus or minus this same thing as square root of 27 multiplied by square root of minus 1, okay, divided by 2. So we have k is equal to minus 3 plus or minus, now square root of 27 can be expressed as square root of 9 multiplied by 3 multiplied by square root of minus 1 divided by 2. Okay, so k is equal to minus 3 plus or minus, now square root of 9 will give us 3 and we have root 3 remaining, right? Then square root of minus 1 is I divided by 2. All right, now we can see that the second and the third value of x, because this is what we have, that k is equal to minus 3 plus or minus 3 root 3i divided by 2. That means that the second value of k is minus 3 plus 3 root 3i divided by 2, and the third value of k is minus 3 minus 3 root 3i divided by 2. Now we need to get the fourth, the fifth, and the sixth value of k, which is very easy to get. Now this is where we are going to get that from here. Recall this place, k to the power of 3 plus 3 to the power of 3 is equal to 0. So we are going to solve that. So we'll write for k to the power of 3 plus 3 to the power of 3 is equal to 0. This is an identity that states that a to the power of 3 plus b to the power of 3 is equal to a plus b, okay, multiplied by a squared minus ab plus b squared. Okay, so if we solve this, or if we express this in this form, so we are going to have our a is k, right, and our b is equal to 3. So we are going to have a plus b, that is k plus 3, multiplied by a squared, that is k squared, minus ab, that is a k times 3, which is 3k, plus b squared, that is 3 squared, okay, is equal to 0. So we have k plus 3 multiplied by k squared minus 3k plus 9 is equal to 0. So from here we can see that k plus 3 is equal to 0, and we can see that k squared minus 3k plus 9 is also equal to 0. So from here we can see that k is equal to minus 3, and this becomes the fourth value of our k. So remaining 2 more values. Interesting, right? Yeah. So here we're also going to use the quadratic equation formula. Now I want you to look at this very well. This is what we have as our k. As our equation, k squared minus 3k plus 9. Now for the other one that we solved, this is what we have, k squared plus 3k plus 9. Now the difference between the two is that this is plus 3k, while this is what? Minus 3k. Now when we solved for the other one, this is what we got, that k is equal to minus 3 plus or minus 3 root 3i divided by 2. So if we should solve this, we are going to get plus 3 plus or minus 3 root 3i divided by 2. Since this is minus and the other one is positive, that's the only difference we are going to get. All right, okay, now thank you so much for watching. Have a lovely day. Bye.